Hi everyone, and welcome to another lesson in Swift fundamentals. And in this lesson, we're going to cover collections in Swift. So if you open your Swift book, Swift fundamental book, you'll see that we're going to cover in Introduction to UI Kit collections. And we haven't covered structures and classes yet. I'm going to postpone this a little bit when we talk about, there's a topic that we're going to cover later on about core data. And before we introduce core data to you, I'm going to cover structures and classes at that time. So let's get started. Why do we need collections, or when do we need collections? Well, a lot of times you're dealing with a list of things instead of, and then, for example, if you have a list of students in your class, you don't want to define a variable for every student in your class, like student names. That would be too much. If you have 20, that means you will have to define 20 variables for each student's name. Or players or teams, whatever, right? So list exists in real life, and then we need to be able to define these lists in programming languages, all right? So the way we can do that in Swift, we have two ways to deal with collections. One way is called arrays, and another way is called dictionary. Now, if you come from a different programming language, if you know another programming language, then I'm sure you are familiar with these topics already, especially the arrays. So what are arrays and how do we define them in Swift? If you notice, an array is a list of values, and usually it is expressed with square brackets around them. So to define an array in Swift, you define a variable, but instead of defining the type of that variable with one, string or Boolean or int, you can make it actually, you can enclose it with brackets around it, square brackets. That means now this is a list or an array, and it's not just a simple value. It could have multiple values, and you can assign these values to the array by using the equal sign. And now you could put these values inside that array. So this means that names is an array of strings that has 3 elements and Gary and Keith. All right. So this is one way to define variables. We're going to look at the other way of defining variables, but this is the simplest way of defining variables. It gets simpler in the next slide. You let the compiler help you determine or infer the types of this array or this list. In this case, we omitted the string type, and then the compiler will infer based on the value that you will put in the list, in the array, that this is a string. It's an array of strings. All right. So yes, the compiler can even infer arrays, not just simple data types. The next example, we could define not only string arrays, you can define basically any object in the Swift language. In this case, we have numbers, and again, the compiler would infer that you actually have integer values in this array, and thus assign the type integer array for numbers. All right. Now, if you want to specify that you don't want, and you want to restrict this array to int 8, for example, another data type, what you do is that you specify that int 8 for that variable or that list numbers. So now you restricted the values in this array to be of int 8. Arrays comes with a lot of nice functions that you can utilize in your programming, when you're programming apps. One of this, for example, is contains. So here we are defining an array of numbers, and it has 4, 5, and 6 in it. You could use a function called contains, just like we did with the string. And then here it says if numbers dot contains 5, that means it searched this array, and this is easy, for us to find out. But if you have thousands of elements, it would be very, very hard to find these elements visually. So what you do, what does Swift allow you to do? It will search for this value in the list of numbers or the array, and if it finds him, or it finds that value, it will get either true or false. So if it is true, it says yes, 5 exists in the array. This is a great example when you're doing search, you're trying to find a value. For example, just a simple example could be the context. You're looking for a particular context, so you can use function like this. Just a note, a side note here, contains function uses the equatable protocol, which is covered actually in the data collection, the next book. All right. You can define arrays in different ways, and we're going to take a look at how we define these arrays. So one way to define an array is you specify the type when you define the variable, and then you put the type of the array inside the square brackets and equal to an empty array. So this one will define an empty array, and it's called my array of type integer. The same thing could happen by using the keyword array, and then you put the type in the less than, greater than signs, and again, it's an empty array. The last way you can define it is simply just put an array and initialize it to an empty array of integers. All right, so here we use the initializer. Okay, so that's how we define arrays. In the next example, I'm going to say how we can initialize an array, specifically this guy here. You can initialize an array and initialize the initial values of this array. For example, we can use the repeating keyword or parameter or function, what you want to call it. So here we say my array int, we're using the initializer, and this initializer has a constructor. If you come from a different language, it has 2 attributes, 2 parameters, repeating 0, and how many do you want. So this will define an array of integers with 100 zeros in it. All right. Why would you use this? It's like if you take, students taking in, they're in a competition and you want to initialize all their values to 0. So you can create the array with the scores, and then all of them will have 0 in it. There's another nice property in the array class, which is count. So what does count give you? It gives you how many elements you have in an array, and that is really important property, because in many cases we don't know. If you want to create dynamic arrays, you don't know how many elements in your array, so you use this count to avoid running into trouble, such as you're accessing elements outside the range of the array. So this way you can keep track of how many elements, and then you stay within the safe boundaries of that array. There's another function property that is called is empty, and then this one will tell you if the array is empty or not, and just simply it will return true if there's no elements in it, and it will give you false if it has elements in it. Obviously, you could use the same thing with count. You can say if count equals 0, that means there's no elements as well. So either these two can help you find if the array is empty or not. And the next example, it's showing you how we access arrays. So when you define an array, usually, like if we take a look at this array names, this array has values, and it has a way a subscript or an index that you can access these elements in this array. So when we define this here, my names, what happens actually internally, you create the variable names, and this array has two elements for now. It has the index for each one of those, and it has the value. So the first element is stored at the index of 0 or subscript of 0. The second element, I have a problem here. These should be quotations around these guys. So the second element will be stored at 1, and the third element is stored at 2. But the count is actually 3. So there are 3 elements, but to access each element, you start with 0. So in this case, the highest index value is 2, not 3. If you use 3, it will give you an error because you'll be outside the boundary of that array. So to access this is how we do it. Let first name equal names, the index of that first element, which is 0. If you want to get the second one, you will say let second name, if you will, and then you say names index of that second element, which Gary, for example, will be 1, and so forth. All right. If you want to change a value for a particular element in the array, again, you can just simply use the index of that element and assign it a new value. So in this example, Gary will be changed to Paul. And then when you print the array, you'll see that Paul is now, the Paul value name has replaced Gary. So that's how we access elements within the array. We use the index or the subscript of that element within the array. The next one, we're going to take a look how we add values to arrays, and then this is called appending values to array. There's 2 ways to do that. One way is you can just use the function append, and the function append, you can append only one item to the array. So in this example, we have names equal Amy. So this names has an array of only one element. And then when I run this names.append, it will add Joe to the array, and usually it's added at the end. So it says Amy, comma, Joe now, right? So after this is executed, we'll have 2 elements in the array. Sometimes you want to add more than only one element to the array, and this is where you can use the plus sign to add a list of elements to the array. So if you want to add the list of elements to the array, what you can do, you can use names plus equal, or names equal names plus, then the list of elements that you want to add to the array. So after this get executed, now we had Amy, then we had Joe, and now we have also Keith and Jane added to the array. So when you print it, it will have Amy, Joe, Keith, and Jane. All right. You could, if you don't want to use this, if you want to add append elements to the array, if you don't want to use this method, you could use in the array there is actually append, and this one is an overloaded method. You could specify content of another array. So instead of just one value, we'll have to add another parameter here. It says content of another array, and then that would do the same thing. So this is how we append or add elements to the array. If you want to insert elements to the array, you don't have to append all the time. At the end, you can insert elements into the array at a particular position, for example, or a particular index. So in this example, we have Amy, Brad, Chelsea, and Dan. And then when I say names dot insert Bob at 0, so what's going to happen? This Amy, it has an index of 0 right now. But when we say insert Bob at 0, Bob will take the place of Amy, and it pushes everything after that. So Amy will be at index 1, Brad index 2, and so forth. But Bob will have an index of 0. So here's the array, how it looks like after we call this insert function. So Bob would be the first, and then the rest is pushed backward. All right. You can also remove elements from the array. And how do we remove elements from the array? You can do it in several ways. One way you can say name remove at. So if you want to remove a name at a particular index, again, you need to be careful here, because if you don't want to remove an element that does not exist, it will give you an error. So what happens is that names.remove at 2. So this is index 0, index 1, this is index 2. So Chelsea will be removed. And then if I say let Dan equal, so Chelsea will have Chelsea will have actually the name that you removed from the list. Let Dan equal names that remove last. So this one will remove the last element in the array. All right. So Chelsea and Dan are removed from the list or from the array. So when I print it, what you're left with is Amy and Brad. There's another function within the arrays class, which is remove all. So if you decide that I want to remove all the players, I'm going to start fresh. Okay, we're going to assign new teams or remove all the students. So what you do is that you can use the remove all function, and that would remove all the names. And now you have an empty array. All right. Okay, so let's look at another way that you can work with arrays is that you could sometimes define a multidimensional array. What does that mean? If we look at the next example, here we have an array 1, an array 2, and then if we say a container array, which is array 1, comma, an array 2, what happens here, it actually create a multidimensional array, which means that you have an array within an array. All right. So how is this going to look like? It will look like this. It's kind of like a matrix. The first row in the matrix has 1, 2, 3. The second row of the matrix has 4, 5, 6 in it. And you can access the row, or you can access an element within the matrix. So how do we do that? So if you want to get the first array or the first row in your matrix, it will be first array equal container array 0. So that's going to give you that first element in the array, or container array, or here in this case, multidimensional array, right? And then if you want to get the second element, if you want to get that first element within the first row, what you do, you say container array element 0, so that will give you this, and then 0 within that element, which will give you this one. So when you print it, we'll print this one here. All right. Where would you do this? If you have like a checkerboard, so like if you're playing a game and then you have a checkerboard or like a chessboard or whatever, so you can represent this easily that way. Or if you're doing any mathematical operation over matrices, you can represent them this way as well. All right, so that's all with arrays. What we're going to do next, we're going to talk about dictionaries. So what is a dictionary and how is it different than array? Now, if you remember, arrays have a list of values, but to access those values, they all have an index. which is always 0, 1, 2 until the end of the array. With dictionaries, you can have your own custom index, if you want to call it that way, or custom key. So for every value, you can assign a key. So a dictionary is like a list of keys and their values. So for every key, you have a value separated by a comma. So the key usually is, a lot of times it's usually a string, but it doesn't have to be. Then colon, and then the value for that key. So to define an array, here's how we define it. So it says bar scores equal Richard 500, Luke 400, Cheryl 800. So what happens now? Every time you want to get the score for Richard, I have to use the key, which is Richard, to get the value. In the array, we use it simply index 0, and then it was giving me 500. Here, we use the key, which is Richard, and then it will give me the value. If I want Luke, I will use Luke to get the score of Luke or the value for Luke. So how do we define it? So this is if we define it and initialize it. So again, the compiler would infer that you're creating a dictionary with the key is a string and the value is integer. But you can also specify it yourself. So we're creating here an empty dictionary with a string, an int, and it's an empty dictionary. All right, so that was the first way you can define an array dictionary. In the second way, what you can the second way is that you specify a dictionary keyword. Again, the key is a string, and it's an integer, and again, it is an empty dictionary. And the last way, you can, when you define the dictionary here, you specify the type. Here, in this case and this case, again, the compiler will infer all of this because you're putting these values in it. But in here, you're specifying the type, which is a string as the key, an integer as the value, and then again, it's an empty dictionary. All right, so how do we add and remove and modify the dictionary? If we define a dictionary with scores, just like the previous example, what happens if we put scores Ali equal 399? Well, what happens is that Swift tries to find that element in the dictionary. So does it exist in the dictionary? Obviously, it does not exist in the dictionary. So what if it does not exist in the dictionary in the first case? If it does not exist in the dictionary, then Ollie will be added to the dictionary. So you will have 4 values now in the dictionary, 4 keys, and their values in the dictionary. So you'll have Richard, Luke, Cheryl, and Ollie. In the case where you actually find the name in the dictionary. So in this case, for example, if I use Luke equal 399, what will happen if you do this, then if we use Luke, it will find Luke here and it will update 400 to 399. So when we specify a value and a key for the dictionary, then if it finds it, it will update it. If it doesn't find it, it will add it to the dictionary. All right. The other way you could do that, you could use the function update value. So what happens if you say let old value equals scores update value, and then you will put 100 for key Richard. Now, if this exists in the array, in the dictionary, it will update the value of Richard, and then the old value is stored in this variable old value. All right, so it depends on the situation. Maybe you do want to get the old value before you remove it. or before you update it. So this is how this is how you do it. Instead of 2 steps, you do it in 1 step. Now, what if it doesn't find Richard? The old value will have nil in it. Yeah. There is a way to check if the old value exists or not, and we will use optionals, which we will talk about this in the future lessons. But for now, we can say if let old value. Do we have a value? Do we have an old value? Think about it that way, which means if it's not nil in a way, then you say the old value of Richard that way. So you don't, if you want to be on the safe side and not get an error, you don't just simply do that because you're not sure if Richard is still in the dictionary or not. You will follow this way, say if let old value equal this, and then you print the old value if it does exist. Otherwise, you avoid those error problems, those nil problems, all right? In the next video, the next part, we're gonna take a look at removing values from a dictionary. How can you remove a value from a dictionary? You can remove a value or remove an element in a dictionary by using the key and then assigning it to nil. So again, you need to be careful about this, right? So when you say scores Richard equal nil, what if Richard does not exist? There's probably going to get a runtime error, right? So you need to use something different than that, right? So what do you use? If you assign it equal to nil, we know Richard exists. So now when you say print score, Richard will be gone. That Richard and his value is gone, right, from the dictionary. Now, if you want to be on the safe side, what you do, you can say if let remove value score remove value. This one for key Luke. Now, again, this would be a better way than doing it this way because you remove it and then you know if it exists, you will not get an error, right? So here it would remove that of Luke and will assign the value to the old value or to this variable, which is remove value. So if we were able to remove it, we'll print the value before Luke has left the team, right? So here, Luke's score was 400 before he stopped playing. And then if you print it out, you'll notice that Richard is gone, Luke is gone, and you're left with Cheryl and her score, right? All right, so how do we access dictionaries? We access dictionaries again by either using the key, that's what we talked about, or you could what you could do, you could get the keys and put them in an array, get the values and put them in an array. If you want to do, special processing, this is another available way for you in Swift that you can do that with. So in this case, if you say players array, and then you're using the class array, and you construct it with the key values from that dictionary. And this array will include Richard, Luke, and Cheryl. And the same thing with scores. You can get only the scores, and you can construct an array using scores dot values. So you can get the keys only, you can get the values only, and then you can construct an array from the list. Again, if you want to find a value in the dictionary, and then you're looking for a key, this is the proper way of doing it. You say if Luke's score equals scores Luke, that way you guarantee you don't get a null exception, and then that it only get executed. This is, remember, that safety feature with Swift. This will get executed only if Luke exists, and then you print look score. All right, same thing here with Henry. All right, so if you looking for Henry score, you say let Henry score equal scores.Henry scores Henry, and then if you found it, you print it. Again, this is optional and optional binding that we're going to talk about this. There's a lesson about this when we get to optionals, you'll understand it better, right? That's the end of collections. Again, arrays and dictionaries, very, very, very common structures in the Swift language and many programming languages. And then you make sure that you know it well before you proceed any farther. All right, that was the end of it, and then I'll see you in the next video.